It's actually from yesterday's lesson. A function f is called what? If f prime is equal to little f. What do you call? That's what we learned yesterday. Antiderivative. True or false? If f is an antiderivative, then f of x plus c is also an antiderivative. That's true. Yeah. Yeah. Plus c is, yeah, but plus c with the specific c, it's a, yeah. Tell me the antiderivatives of y equals x to the negative 1. ln of x. It says all the antiderivatives, so I'm going to put plus c. Okay.
When looking something for this, it accepted only ln of the absolute value.
Yes, yeah.
Unless it says, yeah, yeah. But we just take x positive. So, what's the antiderivative of sine x? Is it negative cosine x plus pi? Yes, that's one of the antiderivatives, right? If you add a pi, then it's one of the antiderivatives. Yes, that's true. True or false? The general solution of a differential equation consists of all antiderivatives. Yes. You integrate it. Free fall is an example of motion with a constant acceleration. Yes. Free fall, the only acceleration is the gravity. To find a particular solution, we need a boundary condition. Yes, that's true. If F1, F2 both are antiderivatives, then they differ by a constant. That's also true. So these are all true statements about antiderivatives. These are all true statements. Okay, today we're going to do 5.5 because that's the continuation of 4.8. And we'll come back and do 5.1. Integration with the substitution. Indefinite integrals using substitution technique. So this is the only technique we have other than all those antiderivatives we know, including power rule. So this is the only technique other than that. Integration by substitution. Integration by substitution is actually the chain rule for integration. The chain rule. So if we have integrand in this format, how? A composite function f of g of x times the derivative of the inside. A composite function times the derivative of the inside. If you have that way, then you can use substitution. You cannot apply substitution for all problems. It has to be in a specific format. That format would be a composite function times the derivative of the inside function. Okay? Then you can apply substitution. Composite function times the derivative of inside function. Example, tell me a composite function. F of x equals, let's say, sine of, not just x. Tell me something because it has to be a 4x. Then times 4. If it is in this way, you can apply integration by substitution. A composite function times the derivative of the inside function. Okay, that's when you can apply integration by substitution. Another example, f of x equals 2x squared plus 3x plus 7 to the power 10. That's a composite function, right? That's a composite function. Which one is the inside function? 2x squared plus 3x plus 7. What's the derivative of that? 4x plus 3. So if we have this function times 4x plus 3 or any multiple of 4x plus 3, you can do integration by substitution. Say composite function times the derivative of the inside function. Okay, so instead of 4x plus 3, if you have let's say 4x minus 1, then you cannot apply substitution. It has to be the derivative of the inside. So it has to be 4x plus 3, but any multiple of 4x plus 3 would be fine. So I can put 8x plus 6. That would be okay. Any multiple of 4x plus 3 is okay. 8x plus 6 or 12x plus 9, anything like that, it's okay. Another example is integral f of x equals 1 over x squared plus 5x plus 7. So which one is the inside function? X squared plus 5x plus 7, right? What's the derivative of that? It would be 2x plus 5. So if we have the function, instead of just 1 over x squared plus 5x plus 7, suppose you have 2x plus 5 divided by x squared plus 5x plus 7, then you can use substitution. Okay, now let's see how we use substitution. Okay, let's start from the first problem. F of x equals now I want to integrate 4 sine 4x dx. Okay, that's what I want to integrate. And when I look at that problem, you can see a composite function, then times the integral of the inside function. We're good. So we can go ahead and use substitution for that. Okay, using substitution, we're going to take u as 4x, which is the inside function. You're going to assume u equals the inside of the composite function. Then we're going to write the differential. What is du? Du is 4 dx. Okay, you write du by dx is 4, then we write the differential, which is du equals 4 dx. Do you agree? Du equals 4 dx. Now I'm going to write this function as sine 4x times 4 dx. And that's equal to sine, what is 4x? What's 4x? U times, what is 4 dx? Du. Now we can integrate it. It's not composite anymore, right? It is simply sine u du, which you can integrate. What's the integral of sine u? Integral of sine u is? Integral of sine u. Negative cosine of u plus c. Then you change u back to 4x. So negative cosine of 4x plus c. So this is how we do substitution. First of all, you have to make sure you can use substitution. To use substitution, we will have a composite function times the derivative of the inside function. Then we take the inside function as u. So the derivative times dx would be just du. Okay, so let's look at this problem. Suppose I want to integrate this. 2x squared plus 3x plus 7 to the 10th power times 4x plus 3. I want to integrate that. This is my question. So which one I would take as u? Tell me. What's the inside function of the composite function?
2x squared plus 3x.
Yes, so I'm going to take that as u. U equals 2x squared plus 3x plus 7. Tell me the derivative. What is du? What is du? That's what this is, right?
4x.
So it's going to be 4x plus 3 dx. dx. And I'm going to rewrite this problem in u. So I'm going to have integral, right in u. Integral. What's this? U to the 10 du. U to the 10 du. Because this whole thing is du. And this is u. So u to the 10 du. How do you integrate u to the 10? U to the 11 divided by 11 plus c. Then we change back u, which is 2x squared plus 3x plus 7 to the power 11 divided by 11 plus c. That is integration by substitution. This is called the integration by substitution. You take u as the inside function of the composite function. Inside of the composite function. Okay. Now let's look at that. Let's integrate that. Suppose I have this function to integrate. Have the question integral dx. So what would I take as u?
1 over.
Not 1 over, just this.
Oh,
Because in the derivative of that is 2x plus 5, right? So I take u as x squared plus 5x plus 7. What's the derivative? Du equals 2x plus 5 dx. So this 2x plus 5 dx becomes du. Am I right? So I can write this as integral 1 over u du. And that is integrable. What's the integral of 1 over u? ln. Okay, let's put absolute value. So it's going to be ln u plus c. Then I change u back to whatever I took. So I write ln x squared plus 5x plus 7 plus c. Okay. So 1 over would be ln if we have the derivative multiplied by that. Okay. Remember yesterday you accidentally put 1 over 7x squared something as ln? Yeah, it works. If you have this times the derivative of that, then it works. Because that's a function of a function, composite function. So integral of 1 over 7x squared plus 1. Yes, I can write that as ln. If I have a 14x dx. Only, okay?
And if you don't, it's not solved.
It's not solved. Yes. It will be in Cup 2. Cup 2, we are going to learn a lot
So
of
excited
techniques.
for that. Yeah.
Solving integration. Yeah. Okay, but now no. Okay. Yeah, Cup 2, whole chapter is integration. Integration and lots of integration. So this is integration by substitution. First, we have to make sure it is integration by substitution. Then you take u as the inside of the composite function. I have two examples done here. Please look at that note. The answer should be in the original variable. So please do not forget to change your u back to the original variable. Choosing u is the main thing here. Uh-huh.
Oh, and okay, so for the ln one, I think I would have known to put it over 1 over. But what rule do we use?
1 over u, the integral is ln.
And anytime we see ln of something, we put 1 over it, and then we
Because the derivative of ln is 1 over u.
right.
So the integral of 1 over u is ln of u. It goes the other way.
But I think I might have missed the step of to get 2x plus 5. So why would we get 2 if we were creating the derivative of it? Why would we?
Because we're changing into u, everything into u.
I'm with you on that.
Yeah.
But if you gave me a problem that said ln of x squared plus 5x plus
ln?
7, yes.
No, we can't do that now. Shouldn't have ln in it. It should have only 1 over. Because the integral of 1 over is ln. You cannot integrate with the ln now.
Okay.
Yeah, we're not learning that this class.
But how would I check my work?
You can differentiate this. Go ahead, differentiate. What do you get? Differentiate the answer.
That's the part I'm missing.
Okay, go ahead.
Tell me that rule.
What is the derivative of ln?
Is 1 over.
Okay,
2x
so you
plus-
write 1 over that, correct? Right? Then you take the derivative of the inside, which is 2x plus 5.
And that's because of the product rule?
No, chain rule.
The chain.
Yeah, chain
I
rule.
couldn't remember what rule.
Yeah,
Thank
this
you.
integration is the chain rule for integrals, this substitution.
Okay, oh, that's right. You were saying. All right, thank you.
So that's why we need that chain rule, okay?
Yeah, thank you.
Yeah, we take the inside, so we need the derivative of that inside to apply chain rule. All right, let's start a problem. It says you take u as this one, but you don't see that on the test, okay? You have to choose u. So suppose we don't have that there, this whatever to take as u. Suppose we don't have that. So integration by substitution. The first thing I would do is, I would rewrite this problem as square root of 7x minus 1 times 7 dx. Why I'm writing that way? So I can see the inside is 7x minus 1 and its derivative is 7. So that's the reason I'm writing that way. So you put the composite function first times whatever the leftover. So put the composite function, write the composite function first. Then whatever left over, you write that with the dx. Okay, that's how we begin. Now I'm going to take u as 7x minus 1. What is du? 7 dx. And that's what exactly we have here. 7 dx. Right? That's what exactly we have. Some people do like this. I don't know whether I don't like that way. Some people solve for dx, which is du divided by 7. Then you write that for dx. That can be done too. So you write integral square root of u times 7 times du divided by 7. You want to do that, or 7 dx is just du. That's better, right? So you don't want to solve for dx, right? Okay, so let's put, so we don't want to do that. So 7 dx is du. So I can write this as, integral. Okay, tell me. Square root of u times du. That's it. So we need to get something that's integrable in u. Yes.
So for you wouldn't put the whole thing?
No, it's the inside of the composite. Or you look at the leftover. That should be the derivative. What's the integral of square root of u? U to the 3 halves divided by 3 halves plus c. U to the 3 half divided by 3 halves, which is same as 2/3. Okay, now I'm going to change u back to the original. What did I take as u? 7x minus 1 to the 3 halves plus c. That's my final answer. This is integration by substitution. That's called integration by substitution. Look at the next problem. Which one is the composite function here? The composite function is 1 over x to the 4 plus 1 squared, right? And the leftover is 4x cubed dx. 1 over. Actually, that I can write like this. I can write 1 over, integral x to the 4 plus 1 to the negative 2 times 4x cubed dx. Okay, now tell me the inside of the composite function. What is the inside of the composite function? Correct. X to the 4th plus 1. Because outside is to the negative 2. Inside is that, right? Outside is to the negative 2. Inside is, okay, what is du? And that's what you see there. See, this is du. So this is going to be integral. Yeah, change into u. Change the problem into u. Yeah, okay. That's integrable. Go ahead, integrate. What's the integral of u to the negative 2? U to the negative 1 divided by negative 1 plus c. Plus c. So it's going to be negative 1 over u plus c. What's u? What's u? X to the 4th plus 1 plus c. This is called the integration by substitution. Integration by substitution. So that integral is negative 1 over x to the 4 plus 1 plus c. So without that, we cannot integrate that function. So let's rewrite this problem as integral square root of 7 minus 3y squared times 3y dy. So we write the composite function first. then times whatever left over there. Okay, what's going to be u? What's the inside of the composite function? What's u? 7 minus 3y squared. 7 minus 3y squared. What is du? Negative 6y. Negative 6y dy. Right? But we have only 3y dy. So I got to multiply what? So how do I get 3y dy from here? I divide by, negative 2. So 3y dy is actually negative 1/2 du. Okay, so it's not just du because we don't have exactly the derivative. We have only a multiple of the derivative. That's fine. Okay, that's fine.
So how would you know that? How would you know if you have?
We got the derivative as negative 6y, but in the integral we have only 3y. So it's a multiple. 3y times negative 2 is negative 6y. That's what we're dividing by that negative 2, which is negative 1/2.
So we would have to figure that out.
Yeah. Yeah, that you'll see when you're here. Okay. Or another way is whenever you see a constant, you can pull that out. Okay. Pull the constant out of the integral. So all I have is y dy, right? So I divide by negative 1/6. I could do that too. So I don't have to worry about the constant at all. It doesn't have to be, there's no need to have a constant there. So I can write this as 3 integral square root of 7 minus 3y squared times y dy. So now I'm solving for y dy. And that's going to be 3 times integral square root of u times negative 1/6 du. Okay, negative 1/6. So if you see any constant, you can take it out. Okay, now we can bring that negative 1/6 out. We get negative 1/2. 3 times negative 1/6 is negative 1/2. That's what we saw at the beginning when we started the problem that way. So it's going to be negative 1/2 integral square root of u du. Go ahead, integrate it. Now we can integrate. Square root of u, we know the integral. What is it? 2/3 u to the 3/2 plus c. 2/3 u to the 3/2 plus c. I can cancel 2 and 2. Then I change u back to 7 minus 3y squared to the 3/2 divided by 3 plus c. This is called the integration by substitution. What is the inside function? 3z plus 4. So u equals 3z plus 4. What is du? Du is 3dz. But all we have is dz. So what do I do with that 3? Divide. Yes, divide. So it's going to be 1/3 du is dz. Because I don't have that 3dz there. I have only dz. So I have to divide by that 3 to get dz. 3 dz is du. So dz is 1/3 du. So this would be integral cosine of u times 1/3 du. I can pull the 1/3 out because it's a constant. All I'm integrating is cosine u du. And what's the integral of cosine u? Huh? Sine u. And what's u? Sine 3z plus 4 plus c. Sine 3z plus 4 plus c. This is called the integration by substitution. Look at the next function. Both are composite here, right? Tan squared, secant squared, both are composite. So how do we decide which one to choose as u? So if I look at this as my composite function, okay, let me look at the other one. First, if I took this as my composite function, then the inside would be secant x, right? Because secant squared. But the derivative of secant is secant tan, which is not there. So I don't choose that. Okay. Now I'm going to look at tan squared. What is the inside function of tan squared? Tan squared. So inside function is tan. What's the derivative of tan? Secant squared, and that is there. So I should take u as tan x. I cannot take u as secant x. If I take u as secant x, I don't have a secant tan there. But I can take tan x as u because du is simply secant squared x dx. So du is secant squared x dx. So what would I get here for a function? I get integral. Tell me integral. Huh? Tan x is u. U squared du. U is tan x. And our function is tan squared. So it's going to be u squared. U squared. And that's integral. What's the integral of u squared? Huh? U to the third divided by 3. You can always check your answer by differentiating back. Okay? You can always check the answer by simply differentiating the answer. When you differentiate this, you should get that. You can always try that. So tan cubed x divided by 3 plus c. Okay. If you have time, please do that on the test so you can make sure your answer is correct. Okay. You use the correct substitution. Same thing here. We're going to take tan x over 2 as u. Because the derivative of tan is secant squared, which is there. That's the reason we take u as tan x over 2. We cannot take sec x over 2 as u. U is tan x over 2.
What's the 7 for?
That's tan to the power 7.
So we just ignore that for right now?
Huh?
We just ignore that for right now?
No, we're going to do u to the 7 when you sub, yeah, u to the 7. So I'm going to take u as tan x over 2. We take the inside. Inside is 10. Outside is to the power 7. That will stay. Yeah. What's the derivative of tan x over 2? What's du? Secant squared x over 2. Is that it? No, we have to do inside. What's the inside? 1/2. Yeah. The derivative of x over 2 is 1/2. The derivative of x over 2 is 1/2. But all we have in the integrand is secant squared x over 2. So what do we do with that 1/2? Multiply by 2, right? Take it to the other side, which is multiplication by 2. So we have 2 du equals secant squared x over 2 dx. Any questions so far? Yes?
Why would you do that and not do it the same for the other problems? Why wouldn't you get the derivative of whatever you had?
Maybe? Which problem? The one
Like the
before?
last one, you didn't get the derivative of the secant squared.
I did. See, u is tan x, du is secant squared x.
But for du, you
Uh-huh.
just got the derivative of x over 2, right?
Yeah. But here this is just x. So we don't have to do inside. The derivative of x is just 1. But here we have a coefficient with x, which is 1/2. That's why we are multiplying by 1/2. That is chain rule. So how would I rewrite this integral problem in u? Tell me. U to the 7 times 2 du. Yes. U to the 7 times 2 du. You can pull the 2 out and integrate it. U to the 7 is power rule. So we pull the 2 out. So it's going to be 2 times integral u to the 7 du. And integral of u to the 7 is u to the 8 divided by 8 plus c. Now we have to change it back to 10, right? Our u was 10. So 10 to the 8x divided by 4 plus c. That's the final answer. Oh, no. What's the mistake? Yes, it should be x over 2. Sorry. 10 to the 8 x over 2. That's our u. Over 4 plus c. Tan to the 8 x over 2 over 4 plus c. The next problem I'm going to rewrite as, I'm going to write the composite function first. Then I'm going to write the leftover, which is r to the 4 dr. The composite function is 7 minus r to the 5 over 10 to the 3rd power. What's the inside of that composite function? What's u? 7 minus r to the 5 over 10. That is u. U equals 7 minus r to the 5 over 10. 7 minus r to the 5 over 10. Okay, what is du? Du is negative 1/10 times 5 r4, right? So negative 1/10 is the coefficient. So negative 1/10 times the derivative of r to the 5 is 5 r to the 4, which is actually negative 1/2 r to, I'm forgetting something. What is it? Du. Sorry, dx. No, not x. dr, yes, dr. So 1/2 r to the 4 dr. But all we have in the integrand is just r to the 4 dr. That's all we have there. So what do we do with that negative 1/2? Multiply by negative 2. Okay. So we have negative 2 du is r to the 4 dr. Now we got substitution for everything. We completely changed the variable from r to u, which is integrable. We changed the variable of integration from r to u, which is integrable. That's why we're doing it, to make it integrable. So this is going to be integral. Tell me. Let me put you to the 3 first. Negative 2 du, right? You can pull negative 2 out, which is always a constant. So we can take it out. So it's going to be negative 2 integral u cubed du. What's integral of u cubed? U to the 4 over 4. Which is negative, what's u? What's u? Yeah, you don't forget that. Okay, you have to change back to your original variable. Have to change it back to the original variable in the problem. Don't leave the answer in u, okay, because that's not the variable. Don't forget to change u back to the original function. Sorry. That's the integral. Remember that formula, power rule, x to the n plus 1 divided by. That's the integration formula. This one, we can write this as integral secant z to the negative 1/2 times secant z tan z dz. Do you see the composite function? Obviously, it is secant x, secant z to the negative 1/2. And fortunately, the derivative of sec is sec tan, which is right there. Right? So all I have to do is take this as u, this. Then this is going to be du. If I take sec z as u, then sec z tan z dz is going to be just du. So let's do that. So this is actually, we are using both derivatives and integrals. Okay. So this is going to be u to the negative 1/2 du. What's the integral of u to the negative 1/2? U to the 1/2 divided by 1/2, right? That is 2 times, yes. 2 times. 2 times. U to the 1/2 is square root. U to the 1/2 is square root. Okay, we'll take a short break. Then continue. Only one section today, the substitution. Okay.
Which is going to be the
If you look at that problem, there are 2 ways to choose u, and you can decide which one is better. Okay. You can choose u as 5x plus 8 or u as square root of 5x plus 8, which I wouldn't prefer. A part is the better one. So I don't think we might have to discuss B part. Okay. Because so far we've been saying take the inside of the composite function as u. That doesn't go with this u substitution. So I wouldn't think we have to discuss that. So we're going to take u as 5x plus 8, but that is possible, okay? You can use that u too. So here our function is 5x plus 8 to the negative 1/2 dx. So what's going to be u? It's there, 5x plus 2. Sorry, 8. U equals 5x plus 8. What's du? Du is 5 dx. But all we have is dx. So I divide by 5. See, that's very straightforward. That's the way it should go. Use the substitution. Uh-huh.
on the test. You won't have to use you won't make two ways.
No. Just integrate. That's all you'll see on the test. So this is going to be integral u to the negative 1/2 times 1/5 du. U to the negative 1/2 times 1/5 du. You can put du, right? Yeah, du. So now I'm going to integrate it. What's the integral of u to the negative 1/2? U to the 1/2 divided by 1/2 plus c. Now I'm going to change u back to the, so it's going to be square root of 5x plus 8 plus c. Square root of 5x plus 8 plus c. Number 14 is a little bit different, so we'll come back to that, okay? I'm not going to have that on the test, but there is one problem on MyMathLab like that. So we'll come back to that problem in a second. Let's finish the other problems. Okay, what is ln of square root of t? Using the properties of logarithm. What is ln of square root of t? 1/2 ln of t. Then we're going to write times 1 over t dt. Why I'm doing that? Because I can see the derivative of ln of t is 1 over t. So I can take u as ln of t. That's the reason I wrote that way. The derivative of ln of t is 1 over t. So I'm going to take u as ln of t. So du is simply 1 over t dt. Du is 1 over t dt. Here both are simple functions. They are not composite. ln of t is not composite. 1 over t is not composite. So I cannot say take the inside of the composite, but we just look at it and see which one works as u. I cannot take 1 over t as u because the derivative of 1 over t is not there. But if I take ln of t as u, then its derivative is there. Okay, that's how you decide if both are simple functions. Here both are simple functions. 1 over t is simple function. ln of t is also a simple function. So we take ln of t because of this, that 1 over t. But if I take 1 over t as u, the derivative is negative 1 over t squared. No, that's not there. So I cannot do that. Okay, now I write this as 1/2 ln of u du. No, 1/2 u. Yes, I can do ln of u. ln of u I can't. Okay, ln of u takes another method of integration. Hmm? See, 1 over t dt is du. We have to have the same, u and du the same. You cannot have u and dt. Okay, what's the integral? U squared over 2, which is ln of t squared divided by 4 plus c. ln of t squared divided by 4 plus c. The next one I can say inside of the composite function. This I can write as integral square root of tan inverse x times 1 over 1 plus x squared dx. Why am I doing that? Because I know the derivative of inverse tangent is 1 over 1 plus x squared. That's the reason we're writing that way. The derivative of tan inverse is 1 over 1 plus x squared. So that's my u. U equals tan inverse x. So du is 1 over 1 plus x squared dx. So I'm going to have this integral. Integral what? Integral u to the 1/2, right? Or square root of u. Square root of u or u to the 1/2. Square root of u or u to the 1/2. What's the derivative? Sorry, integral of u to the 1/2. Yeah. So u to the 3/2 divided by 3/2 plus c. Then I have to change it back. So I write negative, sorry, no negative, 2/3, then tan inverse x to the 3/2 plus c. 2/3 tan inverse 3/2 plus c. 2/3 x tan inverse x to the 3/2 plus c. Okay, this I'm going to write as, okay, integral 1 over sine inverse y times 1 over square root of 1 minus y squared dy. Why am I doing that? Because the derivative of sine inverse y is what you see there. So if I take sine inverse y as u, the derivative is right there. So my u is sine inverse y. U equals sine inverse y. What's du? 1 over square root of 1 minus y squared dy. 1 over square root of 1 minus y squared dy. So this whole thing just becomes du. So what's my function? Integral 1 over u du. What's the integral of 1 over u? ln absolute value, right? Plus c. Okay. Now we change u back to, but I don't mind if you didn't do that on the test. Sine inverse, we just pretend that all variables are plus. Okay. ln absolute value sine inverse y plus c. This integral of 1 over u is ln of u. So it's ln sine inverse y plus c. Initial value problem. Oh, let's go back and do the other one. This is a little different. Okay. This is not like the one we have been doing so far. It's a little different. Anyway, we're going to take u as 4 minus x. 4 minus x. That's what our u is. What's du? Du is negative 1 dx or just negative dx, correct? So dx is negative du. Am I right? But I have an extra factor here, x. So I'm going to solve for x from here in terms of u. Because I don't want x and u in a problem. I want either all x or all u. So I got substitution for square root of 4 minus x. I got substitution for dx in terms of u, but I don't have anything for x. So I'm going to solve for x. Okay, I don't think I'm going to put this on the test, but you have this on my math lab. So I'm going to solve for x. What is x from here? 4 minus u, right? 4 minus u. So there is an extra x there. That shouldn't be there, our usual substitution. Okay, so that x. So we have to solve it for in terms of u, which is 4 minus u. Okay, now let's change everything into u. Integral. What's x? 4 minus u. What is square root of? What is 4 minus x? U. What is dx? Negative d. Okay, so that is a little bit different problem. That x. So it's 4 minus u square root of u times negative du. I can multiply. So I'm going to have integral negative 4 square root of u, then plus, okay, what is u times square root of u? I'm distributing like this. What is u times square root of u? U to the 3/2. So by using substitution, what I was able to do here is get rid of the binomial from the radical and put the binomial out so I can distribute, right? I cannot distribute like this. I cannot go to inside square root. But if the square root is a monomial, I can distribute. So that's the purpose of that substitution. It's a little different. Okay, go ahead and integrate it. It's going to be negative 4 times u to the 3/2 divided by 3/2 plus u to the 5/2 divided by 5/2 plus c. Now we change u back to whatever that is. What was u? 4 minus x. So the final answer is negative 8/3 4 minus x to the 3/2 plus 2/5 4 minus x to the 5/2 plus c. Okay, it's a little different problem because of that x. Okay. You get one on my math problem. Like, there is a square root, then there is x out. All right, now we're going to look at some initial value problems or differential equations. We have done some yesterday. Today, our integration is going to be substitution. That's the only difference. The integration you do to solve this initial value problem will be using substitution. So, dy by dx. So, to find y, I have to integrate this. That's how I get y from dy by dx. From dy by dx to get y, I integrate. I can pull the 4 out. It's a constant. Constant always, it's better to come out. X dx. Tell me u. What's u? X squared plus 8. That's pretty obvious there. U is x squared plus 8. So u equals x squared plus 8. What is du? 2x dx. But all we have there is just a x dx. So it's going to be 1/2. We have only x dx there, so it's going to be 1/2. Okay, so rewrite the problem in u. U to the negative 1/3 times 1/2 du. U to the negative 1/3 times 1/2 du. Okay, what's the integral of u to the negative 1/3? So it's going to be 2u to the 2/3, right? 2/3 divided by 2/3 plus c. And that's going to be 3 times x squared plus 8 to the 2/3 plus c. Three times x squared plus 8 to the 2/3 plus c. Number 19, you have one like that on today's worksheet. Okay. The acceleration of a particle moving back and forth on a line, which is the second derivative of the position, is pi squared cosine of pi t. Okay, you have to find the position. So how many times we have to integrate here? Twice. Yes. Okay. Twice. So first I'm going to find v, right, which is the velocity. Velocity is integral a dt, which is integral pi squared cosine of pi t dt. I don't think we need substitution here because yesterday we talked about that. If you have a k with that, what do? You divide by that. So if you remember that, then we don't need substitution. Yesterday we wrote the integral. Cosine of kt dt is sine kt divided by k. But that comes from substitution. You just simply take kt as u. So k dt is du. dt is 1 over k. So that's how it comes. So if you remember that, then we don't need a substitution. All you have to do is sine pi t divided by pi. That's all you have to do. Or we could use substitution. Okay, so if you remember this, then you just write sine pi t divided by pi. But if you don't remember that, then we have to use substitution. So I take u as cosine pi t. I can move the pi squared out of it. That's a constant. So what is du? No, I don't take u as cosine pi t. What would I take? Just pi t, yes. Don't take cosine with it. So du is pi dt. So dt is 1 over pi. See, that's why we are dividing by pi when you have a constant with it. So this is going to be pi square integral cosine u times 1 over pi du. That's why it's sine pi t divided by pi. Now you know where that division by pi comes from. So it's going to be pi squared over pi integral cosine u du, which is pi sine u plus c, which is pi sine pi t plus c. So that is the velocity. Velocity is pi sine pi t plus c. Pi sine pi t plus c. Question? All right, use the initial condition. Find that c. What's the initial condition? T, huh? When t equals 1, no, that's what we are finding, right? That's the next question. So it's going to be when t equals 0, v is 8. V is 8 and s is 0. So s equals 0 and v equals 8 when t is 0. So when t is 0, v is 8. When t is 0, v is 8. So it's going to be 8 equals, okay, what is sine 0? 0. So c equals 8. So what's the velocity? The velocity is pi sine pi t plus 8. Pi sine pi t plus 8. Now do it again to find the position. Integrate it again. So what is the position? S equals integral. S equals integral pi sine pi t plus 8 dt. Okay, I'm going to use the formula. I'm not going to use substitution there. What's the integral of sine pi t? Negative cosine pi t divided by pi, right? Then plus 8t plus c. So the position is negative cosine pi t plus 8t plus c. Negative cosine pi t plus 8t plus c. Okay, when t equals 0, what's s? S is, S is 0, so what's c? 0 equals negative 1 plus c. So what is c? 1. Cosine 0 is not 0. Cosine 0 is 1. So the function is negative cosine pi t plus 8t plus 1. That is the position function. That's the position function. Finally, we have to find the position at t equals 1. So it's going to be negative cosine pi plus 8 plus 1. That's negative 1 plus 8 plus 1, which is 8. So that's the final answer to that problem. Okay. So we're given the acceleration. You do 2 integration to get to the position. And when you do 2 integration, you get 2 constants. And to find those 2 constants, you are given initial conditions. That initial conditions are when t equals 0, velocity is 8. When t equals 0, position is 0. That's integration by substitution. I think we have done like 19 problems, so should be okay. Yeah, that's a lot. We did only one section today.